Well, welcome to this new tutorial, and today we're going to be looking at how to create effects for your model railway using a PCA9685 servo driver board, but this time using it to control LEDs and then combining that with either an Arduino or an ESP32. The code will work on either. Anyway, when we think about light effects, and just switch screen, we tend to get quite used to seeing buildings like this that have LEDs lighting the various buildings, interiors, exteriors, but you'll often come up against other effects as well. I'm just going to swap screens now to show you one of these. So, as you'll have seen in my appalling phone recording, that's a building that I'm working on at the moment. It's got interior lights, but it also has things like the fire that actually flickers. And what I'm going to do today is do a little tutorial on how to create these effects. Now, the effects we're going to create today is a fire flicker. We're going to look at just a normal light. We're going to look at an arc welder, and we're going to look at crossing lights. Now, what I'm going to do is all of these effects are going to run simultaneously on the same Arduino, the same PCA9685 board. So let's have a quick look at what we're trying to attain here. So what we see in that video is the various effects happening, but all happening simultaneously. And as you can imagine, the fire flicker has a lot of random timings on it. The arc welder also has some random timings, while the crossing lights obviously have to have fixed timings. So what I'm going to show you today is how to write the code to create these effects. Now, as usual, all the code will be available on the Digital Town website. As you can see, the link is there on the introductory screen, and it will also be below the video on YouTube. Anyway, let's get into the code. Now, I'm not going to show you how to wire up the PCA9685 board with the Arduino or the ESP32. For the wiring diagram, if you go to the Digital Town site, you'll actually find there's a link below. I've already done a tutorial on how to wire the things up, so I'm going to avoid that today and just get on with the actual code to make the various effects. Now, this is part of a bigger project that I'm working on. So on my layout, I build modular layouts. So on the current board that I'm working on, I'm going to need at least 3 of these PCA9685 boards because I do have so many effects running. Again, one of the important things with all of these effects is to keep them subtle. There's nothing worse than these things getting too in your face. Now, what I'm doing on my board, I've got a coal fire on the current one. There's an arc welder that's got to go on the next board. I don't have crossing lights at the moment, but I've put that in today because it's one that people seem to use a lot. The other one on my layout that I've not added in is that the lights intensity on my different modules is adjustable from my control panel. Now that's because when I go to exhibitions, depending on the lighting, you can sometimes have the LEDs too bright or too dim, so I'm able to change the brightness. Anyway, let's get on with the code. So first thing, in the code itself there is a link to a previous tutorial on how to use these boards, how to wire them up. As you'll see in that previous tutorial, it uses the wire library and the Adafruit PWM servo driver. Now, in this example, I am just using one board. and this is how we set up the instance of the board. I've called it station. However, on my code for my actual layout, I have a second PCA9685 board. In fact, by the time the module's finished, it will have at least 3. So the second one has a different number 41. Obviously you've got to solder the little pad over on the board. Again, that's in that previous tutorial here, shows you how to do that. But I'm going to show you how you can have multiple boards as well as or a single board. So this code that we're writing today is very, very flexible. In fact, if you wanted to add 50 boards in, it wouldn't make any difference. The code will still run. Now, normally what I do is I put all my variables at the top of the code. In this case, what I've done is I've put the variables above each function, apart from one, which is one variable, which is current millis, which is you'll see is used a number of times. So let's get down to the setup. Setup's quite easy. Just start the serial. I always do that just so that I can see what's going on. We then begin the wire, which is the form of communication between the Arduino and the PCA9685. I then start the station, which is linked to this line here. So we've created an instance of it, and now we're going to actually start it. And then I set the PWM frequency. Again, you don't need to worry about it. Just leave it at 1600 if you're using LEDs, and all will be well. Now you'll notice I've got some code commented out here. This is what you would then do if you were adding a second board, which in my case has been called G-shed, stands for goods shed. So you begin the second board, and again you set the frequency. And finally in the setup, I have set channel 1 to full brightness. Now if we go back to my initial screen, the initial brightness is that normal LED, the second one in from the left hand side. That LED does not change in brightness at all, it's on constantly. And if you wanted any other LEDs that you wanted on all the time, you would just add them here. Now if we'd got the goods shed running and we had an LED for the goods shed, it would be written in a similar way, except just copy and paste this over. Just type in goods shed, and it might be LED number 5, and it could be number 10 as well. And if we had another board, we could just keep adding them on the bottom here. So that's the setup, nothing else to it. Now we come to the main loop, and just so I quickly explain how this works, I've created 3 functions. There's fire flicker, pretty self-explanatory. There's the arc welder, and there's the crossing lights. Now normally those would be the only bits in this loop. However, you will see that there is a bit of code here, and this code switches the crossing lights on and off. So we'll come to that bit of code later when we look at the crossing lights. Anyway, let's get straight on with the first function. So the first function we're going to look at is the fire flicker. Now, before I start on the code, or just to explain the code, one of the things that you have to understand is if you've got multiple lighting effects running, and you'll notice in the code that I use random timings for a number of things, that means that if you want multiple effects, you cannot use delay in your code. Now I've done a separate tutorial, again there'll be a link to that, but if you're going to start putting delays in your code, basically the Arduino is stopped while it waits for that time period to go by. So if you were waiting using a delay for your fire flicker, then all of a sudden your crossing lights aren't going to be working. So in this code, if you adapt it, one of the things you've got to understand is you can't start putting delays in. One other thing that I would tend to avoid as well, apart from when you're testing, is putting serial print statements in, because they'll start to slow the code down as well. And if you've got lots of serial print statements in, it will actually start to impact the way the lights look. So anyway, let's have a look at the fire flicker. So the first thing we do is we take the current time in milliseconds, and then this here checks to see if a certain time period has gone by and whether the Arduino or your ESP32 needs to do anything. This is a very useful way of writing this code, and what it basically means is if your Arduino is on for a long period of time, you won't have a problem when I forget how many hours it is, but after a certain period of time, if you're using millis, you can actually have an issue. So writing the code this way gets around the issue. Anyway, what it's basically doing, we're saying the current millis minus the fire flicker timer. If that is greater than a certain time period, so an amount of time that has gone by. Now the amount of time, it would be really nice to say that's 2 seconds, 4 seconds, 6 seconds, whatever, but actually the fire flicker period is a random number that resets itself every time this function runs. The reason for that is when fires are burning, if you notice, they get brighter, they get duller, and it all happens at random times. So if it's the random time has gone by, and the maximum random time that it's doing, it's between 0 and 500 milliseconds, so between 0 and half a second it will change. So what it does, instead of turning the LED on or off, because the PCA9685 uses a PWM control, that means that you can actually change the brightness of the LED in 4095 steps. So what this thing does is every time the time period, the random time period has ended, it then picks a random brightness, and that's how I get the fire flicker effect to work within this situation. Now you'll notice I've got a line commented out underneath, because what I wanted to do was create some code so that if I wanted, let's say I wanted 10 fires on a particular board, let's imagine I'm building a town, different buildings have got different fires in, I would actually be able to just uncomment this line, and that would mean that now the good shed LED will start flickering. Now you'll notice I've got the LEDs on different channels on the PCA9685 board. So basically any LED that you want to flicker in the way that the LED fire flicker works, you would just put your code, just keep sticking them in here. You can put in as many as you want. Just for your information, by the way, the LEDs that I put into my layout for the fires aren't just the LED. What I actually do is encase them in hot glue. I'll just show you one that's outside of a building. So this is my LED, it's in some hot glue. I then put a little bit of paint over the top, scratch it all up, and as you can see it looks quite effective. For this next one I wanted more of a sort of a wood burner effect, so as you can see there's the little stove. Because of the way that this one's viewed, I wasn't so worried about the finish inside the fire itself. So that's the fire flicker. Now what we're going to take a look at is the arc welder. Now we've all seen arc welding effects, and I'll just show you one now. So just before the video runs, on the end you've got the fire flicker. This LED is on constant. These are obviously the crossings, and this is our arc welder. Now you'll see in this that the arc welder will flash for a period of time with intermittent breaks, very short intermittent breaks. That's just because that tends to be the way that you arc weld. Then there will be a longer break. So let's just start the video. So there's the shorter breaks, then the longer break. Guy's gone for a tea break now, and then it starts again. So as we look at our code, let's have a look at it again. Again, very similar. You start off with the same checking the timings using millis. Now the arc LED has two states. Obviously it's either on or it's off, whereas with the fire flicker I was varying the brightness. For an arc welder you either want that thing on or off, so it's either 4095, which is maximum brightness, or 4096, which means you've turned the thing off. So if the arc welder's state, so as we look at the timer, if it's time to change the state, if the value is 0, it sets it to the LED state to 1, and obviously that's after it's turned it on. And if it's the opposite, it sets the state to 0 and it turns the LED off. Now you will notice there is an arc timer period, which is this period here. I'm using a random value between 40 milliseconds and 100 milliseconds. It's a very small period of time, but by using random it just improves the effect very slightly. Now you'll notice when the arc welder is not flashing, there is also a gap. Now these are very, very small gaps, and these gaps are to create the actual flicker when the person is welding. Now when you weld something, for those who've never arc welded, what you tend to do is you start to weld and then you stop every few seconds, especially if you're like me and you're not very good at it. I've seen some brilliant welders who just seem to be able to weld till the end of the day, but you tend to be welding in sections, then you have to move something around and you weld again. So in the code that I've written, I've got two types of break. There's the one type of break here, which is a break between 1 second and 6 seconds. This is the sort of break that would happen in between welding sections or when you've got to move something. I then create another type of break, which is between 10 seconds and 20 seconds. To be honest, that gap is too short. In reality, if someone goes for a tea break, they're going to be gone for 5 minutes. But for the example that we're using today, if I had to run the video for 5 minutes while you waited to see it flash, it would get frustrating. So in reality, if you're putting this on your layout, I would advise you to probably put an extra 0 on the end of these to create much longer breaks, so that you'll get a section of welding, then you'll get a time period where it stops, then you'll get a section of welding again. Now one other thing that you'll notice is there is an arc break counter target, and what this means is that even the number of times that he does the short breaks will vary each time. This is why I keep using random, and this is why all of this code requires millis as a timer, because if you use delay, it'd be a nightmare trying to do all of these timings. Now the final bit is the crossing lights. Now I was just going to put 2 LEDs in. I put 6 in the end, and you'll see how I've named them. I've tended to name them crossing, left, crossing left, crossing 2 left, crossing 3 left, and then I've got the right hand sides. So if you can imagine, these ones flash together and these ones flash together. Now if you wanted to add more LEDs in, you would just add them in as you want them. Now I've set the crossing timer period so that it changes every half a second. Depending what you're modeling, depending what country, you might want to change that value to whatever value your crossing lights flash at. I've got no idea. I took a guess at it, to be honest. And then we have the crossing code itself. Now, as we go through this, once again, we've got the millis timer, and then you have two states. Now, again, if the crossing state is smaller than 1, it sets it to 1, and this is where the code gets a bit odd. If it is turning the LEDs on, I've put in the code that the trigger crossing lights value must be greater than 0. Now we'll just whiz down to the main loop. So we're down in the main loop. Those are the functions that we've got. Normally what would happen with a set of crossing lights on your layout is they would be triggered. Either you would press a button or there would be a sensor on your layout. Who knows how you're going to trigger the things. But in this bit of code, if this variable is set to 1, the lights start flashing. If it's set to 0, the lights turn off. It's as simple as that. This piece of code here was only written to create myself a trigger. So normally you'd use a button or some kind of sensor. In this bit of code, this is what I've done just to create the trigger to turn the things on and off. Does it every 5 seconds. But obviously you would take this out in your code. So going back to our crossing lights. So the value of trigger crossing lights, when it's 1, the lights will flash. Now you will notice in this code that when we turn the LEDs on, they are only turned on if I've got a value greater than 0 for trigger crossing lights. So basically when it's 1. You'll notice that the code to turn them off does not have the if statement. Now the reason for that is if suddenly the lights were turned off, you want all the lights to go out. So I need to enable the code to keep running and turning the lights out. I just don't want it to turn any more lights on. So that's what that is. So that is one half of the crossing. And then of course you've got exactly the opposite piece of code, which is the opposite flash. So obviously you've got, as one light goes on, the other light goes out and they swap between each other. So that is basically what is happening there. And again, the switching on code has this trigger within it. So that's basically how all of these things work. I hope it's been useful to you. The great advantage of this, of course, is if you wanted a load more crossing lights, just add some more LEDs. That could have been a goods shed board. If you've got more than one PCA9685 board, you can just add more in there. So realistically, you could have dozens of crossing lights across your layout. The other thing that you could do with this code is if you wanted different crossing lights where they weren't all synced together, because that could look a little bit odd now and again, you might just want to create another function and call it crossing lights 1. Just make a copy of the code, and that would then you could then put separate crossings and separate LEDs into your own crossings, and again trigger it how you want. So I hope that's all been useful to you, and I do really enjoy building my model railways. So yeah, I shall do some more effects as I need them. But for now, that's the end of this video. Hope it's been useful, and if it is, click the like and subscribe. Bye for now.